Hello everyone, my name is Justin Pick and I am the pediatric cardiologist at Bronx Care Hospital. This lecture is an introductory lecture that will help anyone learn how to read an EKG. Today we're going to start with a brief introduction on the history of how EKGs came to be. First, the EKG was discovered by Wilhelm Einthoven. He created a machine that used interacting magnetic fields that traced the electricity within the heart. He put his left arm in one bucket of salt water and left leg in another bucket of salt water, and it created a magnetic field. Magnetic fields are created anywhere that there is an ongoing current. So as the current went through the circuit, the wire, it created a magnetic field, and he put another magnet that was stationary over that wire. The interaction between the magnetic field caused the wire to move, and that recording is what led to the development of an EKG. Here is a simplified depiction of what that machine was doing. He had one electrode on one arm. In reality, he had it on one arm and one leg, but for the purposes of this diagram, we'll put it on one arm, one left arm, one right arm. He then had the wire that went through a magnet, and then a line that shone through the magnet, and you could see the tracing of that wire as it moved within that larger magnet. So as the current within the heart was changing, the current through the wire changed, and then the interaction of the magnetic field within that stationary magnet caused that wire to move up and down, and then the shadow of the tracings from that wire would create an image on the tracing on the EKG recording as shown. He then moved the leads to various parts of the body, to various limbs, to create our limb leads that we know of today. So if you take a look at the diagram, we have limb 1, which is between your left arm and your right arm. You have lead 2, which is between your right arm and left leg. And then you have lead 3, which is between your left arm and your left leg. Lead 1 is going to go from the right arm to the left arm as such. Lead 2 is going to go from the right arm to the left leg in this direction here. And then lead 3 is going to go from the left arm to the left leg in this direction here. In a much neater diagram, let me show you the next slide. Here's a better representation of those 3 leads, as I just depicted and drew before. He then could average some of the leads to create 3 additional leads called AVR, AVF, and AVL. AVR is the lead that's going to go towards your right arm, and you average your left arm, your left leg in terms of your negative lead, and you make the right arm your single lead, and so the direction is actually going to go in this direction here. Your AVF is going to be averaging your right and left arm, and then have your left leg be the positive lead, and so the direction is going to be down. And then your AVL is going to be an average of your right arm lead and left leg lead, and then the second lead will be your left arm, the positive lead, so it'll go in this direction. Overall, that'll create various views of the heart, and this is what's known as Einthoven's triangle. The way I think about it is these are different camera angles to see the heart. So if you think about it, this is lead 1, this is lead AVF. We'll label it 1. We'll label this AVF. Okay, we'll label this 2. And then we will label this lead 3. We can then take that a step further and go more three-dimensional. If you put leads on top of the chest, you then create vectors that extend forward to back to front. So here will be the isoelectric point, and you can create lead V1, V2, V3, V4, V5, and V6. Overall, we'll have 12 leads that you see in a standard EKG. Here is the depiction of lead 1, 2, 3, AVR, AVL, and AVF. These are your limb leads right here. And then your precordial leads are from back to front, and they are right here. And together, those 6 and 6 make up your 12-lead EKG. And then there's one lead down here. It's just commonly lead 2, but it doesn't have to be lead 2. And this is your rhythm strip because it shows over the course of the entire recording a single strip from a single lead, and this can be variable. The next episodes will show why these various leads look the way they do and how to interpret them when things are not normal. Thanks everyone for your time. Have a great day.